Hello guys. This is a part two for DBMS introduction. We left at data abstraction, so we'll discuss it a bit. So, for the system to be usable, it must be retrieve data efficiently. The need for efficiency has led a designer to use complex data structure to represent data in the database. Since many database users are not computed or trained, developers hide their complexity from user through several levels of abstractions. Like, as we discussed earlier, there are major three levels, which is physical, logical, and view. So, view level can include view 1, view 2, view to the n number of, which is then connected to the logical level and then connected to a physical. So, this is the total three level of data abstraction. So, let's discuss some of the part of these each level. So, in physical level, the lowest level of abstraction describes how the data can be actually stored. The logical level, the next higher level data of abstraction describes what data to store. And the view level, the highest level of abstraction describes only the part of entire database. So there are different DBMS terminologies also, like data independence. It defines as the property of DBMS that helps us to change the database schema at one level of the database system without requiring to change the schema at the higher level. Data independence helps you to keep data separated from the program that makes use of it. So, in instance, a database states or snapshot, database can change over time as information is inserted and deleted. The collection of information stored in database at particular moment is called an instance of an database. So the now we'll discuss the architecture of the DBMS. So the types of architectures include for one tier, two tier, three tier architecture. So let's discuss some of it. So the first tier architecture. In one tier architecture, the database is directly available to the user. The user can directly sit on the DBMS and use it. That is the client, server, and the database all present on the same machine. For example, to learn SQL, we set up SQL Server, and for a database on local system, sometimes it may referred as centralized system within the center single user system. Then the next is two-tier architecture. The two-tier architecture is similar to the basic client model. The applicant at the client and directly communicates with the database at the server side. APIs like JDBC are used in the interactions. The applications on the client side establish a connection with the server side in order to communicate with the DBMS. An advantage of this type is maintenance and understanding are easier, compatible with the existing system. However, this model gives poor performance where there are large number of users. Then the next and the last is tier 3 architecture or the three tier architecture. So in this type, there is another layer between the client and the server. The client does not directly communicates with the server. Instead, it interacts with an application server, which further communicates with the database system, and then query processing and transaction management takes place. This intermediate layer acts as a medium for an exchange of partial processed data between server and client. This type of architecture is used in case of large web applications. So, as we discuss the three tiers application, there are advantages of it also. So, let's discuss the advantage first. So, the enhanced scalability, scalability due to distribution development of application servers. Now, individual connection need not to be made between the client and server. Data integrity is maintained, then the security is improved. This model, this type of model prevents directly with the interaction of the client with server, thereby reducing access to the unauthorized data. So now, as we have discussed the tiers, we'll discuss the server side system architecture. So the server system can be broadly categorized as transaction servers and data servers. So the transaction servers, also called as query server system, provides an interface to which clients can send requests to perform an action in response to which executes the action and send back the result to the client. Now, the data server system allows a client to interact with the server by making requests uh, to read, update data in units such as files or pages. For example, file servers provides a system file or a file system which interface where the client can create, update, read, and delete files. Data servers for database system offers much more functionality. They support units of data such as pages, tuples, or objects. They are smaller than a file. So, as we discussed all the architecture, now we'll see the classification of database in management system. So, several criteria can be used to classify DBMS, which is classification on the basis of data model, which is then further divided into the relational data model and the object-oriented data model. Then the classification based on user numbers, which is then further divided into single user and can be multi-user system. So the classification based on database distribution, which is further divided into centralized and distributed. As it is centralized, so single user, but in distributed, there are two more types, which is homogeneous and heterogeneous. So why database design is important? So this is a nice question, and we'll try to answer it, which is database design provides the blueprint of how the data is going to be stored in a system. The designing principle defined for a database give a clear idea of how the behavior of an application and how the requests are processed. Any other instance of emphasize can data design is that proper database design meets all the requirements of the user. Lastly, the processing time of an application is greatly reduced if the constraints of designing a high efficient database are properly implemented, which optimizes the system performance itself. Then the database process design. So the database design includes, which can be generally defined as the collection of tasks and processes that enhances the designing, development, implementation, and maintenance of the enterprise's data management system. It simply means mapping of the conceptual model to the implementation model. Like there are many phases for it, to go from the conception model to the implementation model. So the phases are phase one, requirements collection and data analysis, conceptual database design, choice of a DBMS, data model mapping, physical database design, database system implementation, and tuning. So now let's discuss the approaches of the conceptual schema design, which is centralized schema approach, which is a one-shot approach, which is time-consuming, place the burden on a DBA to reconcile conflict, where the integration approach schema is designed for each group or application. So the strategies of the schema design are top to bottom strategy, bottom to up strategy, inside out strategy, mixed strategy. So the phases of database design are technique, which may be like depend on many types of factors, like technical factors, where types of DBMS which are relational, object relational, or object oriented, etc. Economic factors like maintenance, training, operating cost, etc. And organization factors like vendor preference, relational or object oriented. So the phases of database design can be divided, as I said, in data model mapping, which is a phase 4, a physical database design, which is a phase 5, and database system implementation and tuning, which is phase 6, which includes tuning, is an ongoing activity, part of system maintenance that continues for life cycle for a database as long as the database or application keep evolving and performance problems are detected. So this is all about the introduction for DBMS. So thank you.